Hi everyone, this is Anika Kapoor. We are at Popeye and we are doing the recording session with Ram Walvekar on Industry 4.0. Uh, Here we have Ram Walvekar, who is an industry expert from PLM and digital engineering with over 30 years of experience in the industry. Hi Ram, please
Hi,
share
Anika.
your experience and what you have been doing so far.
Yeah, thanks, Anika, for the introduction. And I'm happy to be part of this conversation. To just give a brief background, I'm basically a mechanical engineer, and I did my post graduation in production engineering. I started my career with design in an organization that designs and develops aero engines. I was into CAD CAM and methods engineering and all that. And I went into engineering automation or CAD automation, and maybe the CAD product development, and then into PLM implementation, consulting, and digital engineering, and so on and so forth. So basically, I have seen the life cycle of the product, the way it is developed, designed, developed, manufactured, and everything. And you know, I really appreciate. Uh, your efforts in this direction where you are trying to help the fresh graduates and young engineers to get some clarity on the career options that they would have, right? I mean, this is really a great job.
Thank you.
Yeah,
Thank you.
happy to be here.
Yeah. So, Ram, as the topic that we have today on Industry 4.0, if you want to share what is Industry 4.0 with us and where do we stand now on it?
Okay, so you're asking me about what is industry 4.0, and I'm sure all the young engineers would have already read about it from various sources. So it's possible that they have got overwhelmed with piles of information that's available on this topic on the internet,
I feel
and
like when
so
I was
many
in
different
engineering,
sources.
I was, it was global warming everywhere. We were doing presentations, white papers on global
Yes,
warming. It's like
exactly.
that.
So let's try to bring some clarity on this in this conversation, and also let's make sure that we stay at a basic level without going too deep into the technology aspects of it. So we could probably at a later date take a deep dive in as needed, if in a separate session if needed. Okay. Now, so coming back to this Industry 4.0, or industrial fourth industrial revolution, let's say. So let's talk about the earlier industrial revolutions, right? Um, so as you know, when steam engine was introduced in the 18th century, so it was a big change. So machines, large machines powered by steam power. I mean, steam engines. They did all the heavy lifting, and tasks that were earlier done by human labor, that they were all done by the machines now. And volumes increased, productivity increased, rail transportation started. So it was very, very revolutionary. So people moved from villages to cities, wealth increased, economies improved. So this is what is was revolutionary, right? I mean, this is what is referred to as the industry revolution, or first industrial revolution. Likewise, in the 19th century, electricity was produced, and when this was applied to factories, this led to the concept of assembly lines and mass production and all that. So this again further revolutionized, improved the economy and everything. So this was the second industrial revolution. And now this continued until the middle of 20th century, when electronics and computers started, and the era of automation and digitization began, and actually it's still going on. And and we continued with sophisticated IT infrastructure, communication, and enterprise software, and all these things. And so implementing all these has given huge productivity improvements, and many innovative products are being produced faster, cheaper, and they are of great quality, right? So this is what is referred to as the third industrial revolution, and we are still continuing to be in that phase now.
So we are
Okay,
still in third revolution. Industry
we are,
4.0 is
yeah,
still not there.
yeah. So we have entered into the fourth, but we are still in the third one. Now, what has happened is that in the last 2 decades, there have been exponential improvements in computing power, storage, and communication, and also sensors, as you know. And the prices of these have fallen so deeply, so steeply, and making using all these has become very, very affordable. So these developments made it easy to develop some foundational technologies such as cloud, IoT, big data, artificial intelligence, and simulation. So these are all the foundational technologies that were developed because of the factors that I mentioned. They what evolved in the last 20 years.
Okay.
Now, um, so the other thing is at the same time, due to world being hyper connected, so we are all connected and we know what's happening in the world, right? And our awareness is increasing and expectations are also increasing, right? So these, when you add to the expectations from the regulatory authorities, right, they throw a lot of challenges to the manufacturers. And at this time, when we are grappling as to how to address these customer needs, how to address the regulatory authorities requirements and stuff like that, luckily these technologies evolved, and then we had these foundational technologies, and combining these actually led to an altogether new capabilities that we had never thought about before. So this can bring not just incremental change, but changing the overall business model altogether. So the idea behind this is what we refer to as the fourth industrial revolution or Industry 4.0.
Okay. So, what are the various business drivers around Industry 4.0? Why Industry 4.0 basically?
Okay, so I just briefly touched upon that. As I mentioned, we are a hyper connected world. So every day we log on and then browse the internet and then see what's happening around, when what kind of products are available, and what is the advancement that that's taking place somewhere and all that. So the expectations are increasing, ever increasing. So what I want today, I don't want tomorrow. I want something new, right? So asking for more and more is becoming a habit, and I want more and more customized products to meet my needs, right? So and these have been ever changing requirements, and then there have been more requirements, as I was mentioning to you, from the regulatory authorities for regulatory compliance, and competition is increasing globally, due to which manufacturers want to bring down both the prices and time to market steeply and offer better functionality and better quality to the customers. Otherwise, they will be out of business. So at the same time, as I was mentioning, these when these foundational technologies have emerged, and then we also have some social aspects affecting some of the economies in the world. Some advanced countries, they have aging population, and they have scarcity of manpower, and moving the manufacturing to low cost countries may not be a good option for them.
Okay.
How can they still keep the manufacturing in their own country and still be cost competitive? So so
True.
all these things, are the business drivers, I would say.
Okay.
And
Okay. So, yeah, sorry if you want to go ahead.
no, basically what I want to say is that what these are the business drivers, but at the same time, manufacturers, they want more, right? So more avenues for revenue. So another concept of servitization emerged, where the customers were thinking that, okay, instead of selling the products, why don't I sell services? So the customers will pay only for the number of hours a particular product has been used, and the complete maintenance and service of that product is with the manufacturer, and the customer pays only for the usage. Something like how an engine manufacturer would sell the number of hours to a customer rather than selling an engine itself, and the customer is also happy because he doesn't have to really worry about maintenance and servicing of that. He doesn't have to staff anybody, and he just pays for the number of hours an aircraft has flown. So this is the new trend which is coming. And and when these are all from the business side, as I was mentioning, we have these technology improvements in computing, speed of computing, speed of network, and storage, sensors, and everything. And a combination of this, for example, let's say that one of the elements could be very good in itself, the other one could be very good in itself, but if you take all these four or five and bring them together, it then offers a groundbreaking solution that could potentially completely change the business landscape, as I was telling you. So basically, it's the uh, business drivers, and then we have this industry 4.0 happening because we have the technologies available to take care of these business issues.
So, Ram, a personal question probably, but what fascinates you about Industry 4.0?
See, what fascinates is that all these years we have seen solutions in silos, right? We have seen solutions in silos. So we have seen PLM, we have seen ERP, we have seen supply chain, we have seen robots, we have seen MES, we have seen plant automation, so on and so forth. But and we also have seen cloud, and we also have seen robots and everything, right? But when you combine everything,
Mhm.
with each one cross leveraging the other, the kind of solution it is coming out with is with so much of abundant capability that's we had never it's unprecedented, I would say. And and the fascinating thing is that people are actually seeing the benefits of these now, and they are able to see the benefit, and then definitely it will be an exciting path, I would say, for the young engineers to look give a serious look into this.
So, okay, what is the workforce of tomorrow looks like for Industry 4.0? So, for example, the students who are there right now, either in the schools or in the engineering colleges, what does what does the workforce of it look like? What kind of various aspects of what are the pillars basically going to be of Industry 4.0?
See, one is, none of the existing technologies that we have, it could be programming or program management or, anything for that matter, it doesn't go waste. But only thing is that we will have to have an incremental knowledge that is tuned to what is applicable for Industry 4.0 kind of a scenario. It could be in cloud computing, or it could be in analytics or data science. Data science is the most vital thing of that, because that's where a lot of logical decisions are taken, and the decisions are passed on to the equipments for becoming autonomous, and then run efficiently. So basically, I would say that the workforce of tomorrow will be much more aware, much more knowledgeable about the new technology trends that are happening. And another thing is they have to be in the habit of always learning, because we have something today. It doesn't mean that we can still hang on to this after 5 years. Things will definitely change. There is disruption happening at a much faster pace, right? So you have to always be learning and then adapting yourself to the new things that are always coming.
That's true. So I think that is the motto of our platform too, Popeye, that we are trying to bring in because, as if I say about myself, whatever I learned until my 12th grade wasn't applicable in my engineering, most of it, but the basics always remain same. But whatever I
Exactly.
learned in engineering, it's not was not used in that, training time, and what was in the training was not in the actual work.
You're right. And it's also a warning that don't give up learning. If you give up, then you are at the risk of being redundant and not being employed. So
Right.
that, yeah, so you have to keep that in mind.
So now coming to that, what are the different courses, if you have, you think you talked about data science, you talked about big data, talked about data analytics, anything, any suggestion you have for the young engineers who are still in college, or maybe not only engineers, if anyone else you think should be able to get into this domain, what they should be looking up to, what kind of courses that should they should do?
Okay, see, one thing is um, the core competency of an application engineer or an automation engineer, electrical engineer, industrial engineer, or embedded systems developer or system integrator or test engineer. See, all these do remain. Okay, but at the same time, you have to have um, uh, your existing skills tuned to the new paradigm. For example, now everything is going to be data driven, and everything is going to be exchanged on the internet via sensors and connectors and stuff like that. And then you have a lot of simulations and additive manufacturing, all those kind of things taking place. And basically your core knowledge has to be there, and then you are applying all the new developments into your core technology to make it adaptable to the new industry 4.0 scenario. So what I would say is that some of the core things like cloud technology or cloud computing, internet of things, or data science, of course, it includes artificial intelligence, machine learning, big data, and all those kind of things. And some of the concepts like digital twin and digital thread are also essential. And for the hardcore engineers, now you cannot just take your crude engineering processes and then say, okay, I'm going to digitalize everything and then reap the benefits of digital engineering, right? You have to also build in some discipline in your processes. So learning concepts like model based enterprise or model based systems engineering, they're all very important. um, you know I would say that these are some of the areas that people have to really pay attention to.
Okay, thank you for that. And I have a question that I want to really understand. So, what will be the future factories look like? So, and how different it will be from the current one?
Okay, see.
That really fascinates me. Sorry,
All
I
right.
had to ask
Okay.
this question.
Okay. So, what happens in the factory now? For example, the most sophisticated factory is that you have your product lifecycle management, where you actually define the specifications of a product, you define the bill of materials, and then you generate your manufacturing bill of material. And then there is a supply chain, and then you procure the you know components or parts or raw material or whatever, and then start manufacturing it in your plant. And then you have automatically generated instructions that are executed, and then you capture everything in your control everything using your MES tools. Ultimately, everything is measurable, everything is monitored, and then you get an output, and then finally you will get an efficiency to whatever extent possible, right? Because you are actually following your ERPs and MES and supply chain, which are all productivity improvement tools which give you a lot of operational efficiency, right? And PLM gives you a lot of top line growth as well. Now, still, there's a limit to this, there is a boundary to this. It can all work within a particular boundary, where you have to always intervene. Whatever the extent of automation it is, you have to always intervene and monitor. And then you have to intervene to make new place new orders for the inventory or machines, or take care of the machine maintenance yourself, because if something breaks, you have to call the machine manufacturer and ask them to come and do the maintenance. Or let's say a factory floor or any asset in the factory, you will have to call them and then ask for maintenance and stuff like that. But in the future, what happens is the factory. Okay, so before that, I want to also tell one more thing. I was to you about the mass customization, right? I mean, individualization. So I need some new part to be manufactured according to my likes. So when a manufacturing line is already in progress, all parts are manufactured in a similar way. Can you have in the same line 10 different designs being manufactured in 10 different ways? No, right? And today it's very expensive. You have to stop the line and introduce and make some changes in the operational processes, which is going to be time consuming. But in the future, what's going to happen is, because I'm talking about mass customization, the product, the product that is being, the product that is getting manufactured, that itself is intelligent. It can drive the operations. It can tell, okay, now I am coming with these specifications. I want these tools to be operated on, and you know, it goes in an automated way without actually impacting the speed of the flow in the production line. And let's say that um, a particular and you have 10 different lines, and out of which one or two lines, for whatever reason, they are getting stuck or delayed or something like that. The whole factory being intelligent, it automatically diverts the load to the others. Or if let's say it detects that, okay, loading the same things into the other four lines becomes expensive, because it has got a sister factory in the nearest locations, it will probably ask those factories to take up the load by itself. I mean, without any human intervention, right? And the other thing is, there are several machines in the factory,
That would
right?
be
I said,
fascinating, actually.
yeah,
I'm just thinking about it.
yeah, and there are different machines in the factory, and then let's say, because you have tons of historical data that you are analyzing, and then you have some predictable prediction model derived out of that. If let's say in the manufacturing a particular behavior is detected, then the system would automatically know that, okay, I have only maybe 20 more hours of running here, and then within that I have to replace this part, within that I have to do some maintenance, I have to do some oil change here. So it forewarns, and then the robots actually perform those actions without any human intervention, so that the flow goes uninterrupted, right? So a lot of things, like this, so that the robots talk to each other, and then the machines learn by themselves. And then if the machine detects that there is a quality issue or something like that, it can self correct by changing the parameters. And then still, it may not even happen such that it actually sees a drop in the quality. It can even predict that, okay, there could be a drop in the quality because of these change in parameters, so it self corrects, so that it never produces anything which is of low quality.
Okay.
Yeah. So,
Thank
so
you.
and it
Yeah.
can proactively order for the raw material. It can all that, it can happen automatically.
So when do you think we can basically have, we can go witness a completely Industry 4.0 implemented factory? When do you think? How long it is going to take?
See, this is a journey, okay, and many people are onto this journey, and then very exciting journey, I would say. And then many people have drawn out I would say, multi-generational implementation roadmap, and they're into phase one, two, three, four, and they have already started seeing results out of that. And then, though it's not a there's no shortcut for this, but people are actually seeing the results. And then you can uh, say that maybe in the next 4 or 5 hours you will have more examples of more success stories coming from different players. But now also we do have a lot of positive outcomes of all the initiatives that the customers have taken.
So, just this is my last question. What are the different industries this Industry 4.0 will be applicable to?
Okay, so when you talk about an industrial revolution, a revolution is not restricted to an industry by itself, right? Maybe, though Industry 4.0 is always referred to as manufacturing, it can be applied to buildings, it can be applied to cities, it can be applied to healthcare, anywhere. I mean, because these technologies can be exploited in all fields, right? But we are talking about the manufacturing, and the reference here is to basically get the industrial productivity, right? And that's what we are referring to. But the applicability is quite vast, and it's applicable everywhere.
Ram, that was my last question. Do you have anything else that you feel that we might have missed during the discussion?
I think we covered pretty much everything. We talked about the foundational technologies. Only few things that I would like to add are, in terms of the technologies that are leveraged in Industry 4.0. Um, we talked about cloud technologies. We talked about Internet of Things. Um, so one thing we need to also know is interesting to know is that when we talk about the cloud technologies, it's not just about storage, computing, availability, and all those kind of things, right? Most of the cloud service providers are providing lot of solutions, host of solutions for the Industry 4.0. It could be in the area of digital twins or Internet of Things, or so this makes it very, very easy for a quick deployment of the solutions to a customer. And and of course, uh, big data we talked about, and the cyber security is one very important thing. uh, you know about the threats on the internet, right? I mean, anything can be hacked and everything. When you have billions and billions of vital components and products connected, and then interacting with each other and interacting with the central server, there is always a there's always a possibility of a security threat, somebody hacking and stuff like that. So there are robust levels of security that you can apply, and this is a technology in itself, which is again a very good career option for people to pursue. Cyber security is one thing, and then additive manufacturing is another very interesting topic where complex components can be manufactured and near to the customer, right? I mean, you can choose the location of where it has to be manufactured if you have a kind of a 3D printer. So this is being leveraged. Augmented reality is another one where, something like a Google Glass you would have seen, and then somebody at the remote place can assist an operator to go and do a maintenance by himself without actually having an expertise in the machine. So he can be guided through the this augmented reality solution. And and the most important thing that I didn't stress upon is the simulation simulation and system integration. So simulation, we all know, right? I mean, we know all the time. We have done the finite element analysis, or we have simulated a product, we have simulated a factory floor, we have simulated a machine and stuff like that. But all those are simulated using a design data. But when you have a live data coming from a sensor, right? That makes all the difference. You are actually simulating using a live data that is coming from the operations, and that's where the concept of digital twin comes, where you can play around and you can predict, you can um, you can do the performance monitoring, so on and so forth. You can do in a digital twin.
Right.
And then when we talk about this integration, you have uh, complete value chain which is connected, right? And then the data coming from, whether it is the design, build, manufacture, operation, service, anywhere you go, the data is coming into the digital twin, right? And that's what is the complete repository what we are talking about. And the conduit to feed the data into digital twin is the digital thread, which ensures what we know as a single source of truth. And then we maintain this digital continuity, and this is one of the vital, I would say, requirements behind the success of I would say Industry 4.0. So this is something that we have to keep in mind. And we talk about PLM and everything, right? I mean, so this is an extension of all those concepts.
Okay. Thank you, Ram. We had a pretty knowledgeable sessions. We'll probably have more sessions with you on more topics. Thank you so much.
Sure. All right, Tanika. Nice talking to you.
Thank
Yeah.
you.
Bye.